Hi, my name is Kanish.
Hi, I'm Shrey.
My name is Ishan Javali.
My name is Madhu Sharma. According to the World Health Organization, there are approximately 2.2 billion people globally who have issues related to their eyes. Out of these 2.2 billion people, it is estimated that 1 billion of these issues could be prevented or have gone undiagnosed. The leading causes of eye issues within the world are due to addressing these issues once it's been too late, so when the damage has already been done. Today we'll be investigating diabetic retinopathy, one of the possible eye complications. Diabetic retinopathy is a complication of diabetes which is caused by damage to the blood vessels in the tissue at the back of the eye, also known as the retina. The current problem within eye diagnosis is that it is too expensive. If the diagnosis is taken too late, then the complication could have caused more damage to the eyes, resulting in more expensive treatments. This expensive diagnosis isn't even covered with insurance. Additionally, there are a shortage of doctors right now within the COVID-19 situation, where doctors should be more focused on helping patients who are prone to risks. I present to you RetinoScan, a fast and easy at-home self-diagnosis with functionality to share results with your doctor. We use machine learning to train a model to detect healthy and retinopathic eye images and package it into an Android app where it can be used by anyone, anywhere. After taking a picture of the eye, the model predicts if your eye is retinopathic or healthy.
And the biggest difference between normal and unhealthy eyes in terms of diabetic retinopathy is the amount of hemorrhaging visible. So our aim was to train the neural network to recognize that hemorrhaging and assign severity to it. We initially wanted to be able to give a reasonable estimate to this severity by assigning it to one of the four stages of disease, but we decided to let the doctors decide that, since even they can disagree on the classification. Our first challenge was an extremely imbalanced dataset that had differing resolutions and zooms. We first tried to make this a categorical problem by trying to distinguish between levels of disease, but that did not work. There was not enough data for the higher levels of the disease to train a model. Instead, we decided to make a binary between healthy and signs of disease so that the user can further clarify by going to a doctor.
So first, to standardize all the images, we took all the images in our dataset, cropped them to remove all the excess black zones, and then resized it to a common 256 by 256 resolution. After this initial image processing, we needed to extract all the features that were correlated with retinopathy. And so to do this, we took the original image and blurred it, and then took a global average difference between the original and blurred versions. And this resulted in a nice pre-processed version where all the hemorrhages and aneurysms were nicely contrasted with the background. After pre-processing, we used transfer learning to train a convolutional neural network where the first 5 layers were the 5 layers of a model called EfficientNet B0, and the remaining 3 layers were added with the Keras API. And the last layer was a sigmoid activation layer that mapped the output between 0 and 1, 0 meaning the image was healthy and 1 meaning it was retinopathic. So after training and evaluating, on the left you can see confusion matrix, and on the right you can see an example prediction it made. We managed to get this network to around 72% accuracy, and this is actually a very conservative estimate because in reality ophthalmologists themselves differ between diagnoses of particular images.
Now for a demo of the RetinoScanner app. Users start by taking a picture either from the camera or picking one from the gallery. I will start by selecting an image of a healthy eye and uploading it to RetinoScanner. When I press Get Results, RetinoScanner instantly diagnoses the eye as being healthy using the TensorFlow Lite model we developed and deployed in the app. Now we look at an example where the patient does have diabetes retinopathy. After uploading this image, the app classifies it as having signs of retinopathy. It then tells the user that they may have it and should consider consulting a doctor. The RetinoScanner simplifies the process of sending the results to the doctor through the press of a button. In this manner, RetinoScanner is able to provide users with instant diagnosis for diabetes retinopathy, all from the safety of their homes. Thanks to its versatility and ease of use, RetinoScanner can be expanded to identify other eye diseases such as glaucoma and strabismus or cross-eye. In addition, a sign-in system can be implemented so that users are able to view their specific test results over time. To add on to this, a monthly notification system can be set up to remind them to regularly check up on their eye health, a process that takes mere seconds. Another extension that can be made is to pair the app with a lens so that users can take a clear image of the fundus of their eye. The fundus is the inner lining of the eye which gets affected by the hemorrhages caused by retinopathy. We could design a 3D printed magnifying lens that would enable users to accurately capture the fundus of their eye in an image that the app could then provide instant diagnosis for.